All right, we're reviewing our exponent rules that we should know from grade 9. In terms of vocabulary, we have a number up in the air, and that thing is called the exponent. And then we have the number that is down in the bottom part, and that is called the base. So we'll write base in here. And then we have, I'm not very quick at doing this, sorry about that. And then when you put those two pieces together, that's called a power. So often people will confuse the issue and say that we've got 5 to the power of 2, and it's really 5 to the exponent of 2. The 5 with the exponent of 2 is called the power. So power should go in there. There we go. Okay, so the whole thing in the circle is the power. All right, rules. We're going to review a few rules here today. Multiplying powers with the same base. So I have this first example here, and it has already been filled in for you. If we have 5 to the exponent of 2 times 5 to the exponent of 4, we can write that in the expanded form. Expand means to multiply when we're talking in math terms, so multiplied form. Multiply. So we have 5 to the exponent of 2. That means I've got 5 times 5, or 2 factors of 5. And then 5 to the exponent of 4, that is 5 times 5 times 5 times 5. And then collectively, that makes a total of 1, 2, 3, 4, 5, 6 factors of 5. So factors are things that get multiplied together. Factors is a term that we're going to be using a lot throughout this unit. We've got 6 factors of 5, which then as a single power can be written as 5 to the exponent of 6. So you can do that for the rest of these examples. You can put this on pause, and then you can check your work. Okay, if you check your work, in the end, in the second row, we had 3 to the exponent of 7 as a final answer. We have -2, which needs to be in brackets, to the exponent of 6 on the outside of the brackets, and then we have x to the exponent of 5. Now, if we look at how we can go from the original question, the original product, to our final answer, you should remember there is a rule. If I take the exponents that I have, the 4 and the 2 on the first example, 4 plus 2 gives you the 6. So the base stays the same. The 5, the bottom number stayed a 5, but then we add the exponents together, and that gave us the 6 as our exponent. So down here at the bottom, our base was x, the exponent was a 2 and a 3, add those together, you get x to the exponent of 5. So we're going to write the rule in below where it says when multiplying powers with the same base, the base will, you keep the base the same, the base does not change, you don't multiply the base number together, but then you add your exponents together. Okay, so you keep the base as it is, you don't change the base at all, and then you add the exponents together to get your single power. Now we're dividing powers with the same base. Again, we're going to write things in expanded form. We're going to state the number of factors that remain after simplifying, and then we're going to write as a single power. So the first one, again, has been done for you. We have a base of 5, and we have 5 factors of 5 being multiplied. So 5 to the exponent of 5 is this 5 times 5 times 5 times 5 times 5 times 5, 5 times 5 times 5 times 5 times 5. Yeah, and then we're dividing that by 5 to the exponent of 3. So instead of writing the line in 2 dots, I've actually put in the divide, like a fraction line there. And then we have our 5 times 5 times 5 on the bottom. And if we're multiplying and then dividing, we know that things are going to cancel each other out. If we have a times by 5, but then we're dividing by 5, they really make a 1 overall. 5 divided by 5 is 1. Similarly, I could take the second 5 with the top and the second 5 on the bottom, and they will reduce each other, cancel each other out. And then the third 5 on the top could reduce with the third 5 on the bottom. And then in the end, we're left with these 2 factors of 5. So I've written here 2 factors of 5. So that gives us, as a single power, 5 to the exponent of 2. So you can go through the remaining examples there, and then you can check your work. So on the next example, you should have ended up with 3 to the exponent of 3. We've got 2 3's on the top that will reduce with the 2 3's that are on the bottom, leaving you with 3 factors of 3 there. And when we check the second last example in the dividing, you should have ended up with one factor of -7, and then that ended up with -7 to the exponent 1, which is just equal to -7, and then you have 4 factors of x for the last example in the dividing, which leaves you with x to the exponent of 4. So again, when we're looking for patterns, you should notice that your base stays the same, so 3 to the 5 divided by 3 to the 2, that ended up with a 3 to the exponent of 3. So really we're keeping the base the same, but then we're subtracting those exponents to get the exponent of 3. The base in this one stayed as a -7, then the exponent 3, take away the exponent of 2 gives you the exponent of 1. And likewise here, the base stayed an x, a 6, take away the 2 gives you the 4 here. So we can write a rule for that. Apparently, I'm having trouble. Okay, and then the last rule that we're reviewing today is the power of a power rule. Now that means we have a power. So here we have 5 to the exponent of 2, so that is a power, but then we're taking that power and making it into another power, where we're taking 5 to the 2 as a base and now making a new exponent of 3 on that. So really it means that we have 3 groups of 5 squared. So the exponent 3 tells us we're going to have 3 bases that are 5 squared. So here's my base of 5 squared, which is 5 times 5, times a base of 5 squared, times a base of 5 squared. So I could have written 5 squared times 5 squared times 5 squared first, and then each one of those is going to, the 5 squareds becomes the 5 times 5. So altogether that gives us 6 5s being multiplied together, so 6 factors of 5. Factors means to multiply. And as a single power, the base stays a 5, but there's 6 of them, so the exponent becomes 6. Try the next ones and then see what you can come up with for your rule. Okay, you should have noticed that for the second one you've got a 3 to the exponent of 8, and for the last one you've got x to the exponent of 9 as a single power. So single power, one base, one exponent. And if we look at where 8 comes from, I have a 2 and a 4 here. If I do 2 times 4, I get 8. And here I have a 3 times 3, and that is what's giving me my 9, and my 3 times 2 on the first one gives us the 6. So the base will stay the same again, keep it as it is, and then we're multiplying our exponents here. So keep the base as it is and multiply the exponents together. Now on the back side of this sheet are some examples where I'm asking you to simplify some things using these exponent rules. So give them a try, see how you can manage with that, and we will take up some solutions later.